Hello, everyone. My name is Lynn. My environmental toxin presentation topic is air pollution. And this is my first slide. I'm going to talk about historical background about the air pollution. People have been aware of centuries of the effects of airborne pollutants on human health. Dr. Madela D.W. stated that environmental health, that tons of lead, copper, zinc, and mercury were used annually in industrial operations. And this was noted as early as during the Roman Empire. In, then back in the 1300s, England banned silver and armor smithing because they realized that silver and armor smithing contribute to air pollution. And in 1895, Pittsburgh Air Pollution Ordinance was passed to reduce the amount of contaminants being released by steel mills. And in 1911, Boston Air Pollution Ordinance was the first to acknowledge that air pollution has regional and national as well as local effects. And reports from 1860 and 1960s also indicates that tens of thousands of people have been developed respiratory and cardiovascular ailments as a result of various airborne contaminants. Since air pollution was so severe in industrial areas that 75% children and adults have respiratory disease based on Molson 1990 research. The effects of air pollution on human health and on the global environment have been widely recognized today, and the laws and regulations are developed to address the negative effects caused by the air pollution. I recommend you to look up the Clean Air Act amendments of 1970, 1977, and 1990 to learn more about what have been required and discussed in the laws and regulations. This slide, I'm going to talk about national air quality standards. In order to investigate the relationship between air pollution and adverse health efforts, I reviewed several epidemiological studies on outdoor air pollution and extracted air quality trends data from the United States Environmental Protection Agency, shortened by EPA, the website to develop this table. The table summarizes 6 key pollutants that the EPA established and listed in the National Ambient Air Quality Standards. Those pollutants include carbon monoxide, lead, nitrogen dioxide, ozone particulates matter, PM10, and PM2.5 was excluded in this slide, and sulfur dioxide. Under each category, you could see I added information on pollutant entry and health effects. And concluded with the at-risk population and national average trends. It's encouraging to see all 6 pollutants have shown a declining trend since the 1980s, with sulfur dioxide experiencing the largest decreasing percentage and ozone the smallest. You could see the health effect and pollution entry under each pollutant category are identified at multiple levels in humans, including pollution level, population level, body organ, and function unit. And the major indoor air pollutants and sources and effects are demonstrated in this slide. And the pollutants are major gases like carbon dioxide, sulfur dioxide, volatile organic compounds, reactive chemical particles, and biological allergens such as dust mites, cockroaches, algae, pollen, toxins like fungi, rhinids, fatigue, and bacteria, endotoxins, and also as well as complex mixtures such as tobacco smoke. And you could also see the sources under each pollutant and the toxic effects. Most symptoms are respiratory tract irritation, inflammation, and also impairment of psychomotor facilities, headaches, and the skin and eye irritation, upper and lower respiratory tract, such as that. Now we have a general idea about what those outdoor and indoor pollutants are and how they enter individuals' body and their effects on people's health. In the next few slides, I'm going to talk about how to identify hazard sources and how to conduct an exposure assessment and risk management. You could see the chart here is to show how to identify sources and exposure routes. Usually, it starts with emission sources, and then from air, I categorize indoor, outdoor air, and indoor air, and those are all can be demonstrated by inhalation or thermal contact with air pollute. And by the end, it will be represented by the internal dose. This chart shows an interdisciplinary approach is necessary and required to conduct this process. It also involves borrowing techniques and methods from numerous scientific fields, including chemistry, biochemistry, pathology, and more. This process examines toxic interactions from the level of the molecular all the way to population level. And this slide, I'm going to talk about key steps in toxicokinetics. Usually, the major key steps involves exposure, absorption, distribution, metabolism, and exertion. You could see the movement of toxic compounds from the indoor and outdoor air into and within human body can be concluded by using this flowchart. From identify hazard exposure and resources to the end effects on organs and physiological systems. This process can help to establish biological bias for regulation and to identify the safest chemicals for our use and to set acceptable levels of exposure for chemicals that may be dangerous. To adverse a chemical cause negative health effects on humans. The dose response relationship is investigated in next slide. Here, you could see the x-axial is from minimum dose to maximum dose, and the y-axial is toxicity responding rate. And the midpoint, which is peak of the curve on the graph, indicates the dose that produces effects in the largest percentage of the human animals. From the graph, you could see that a major portion of this curve is linear. That means the response is directly related to the dose or concentration of the chemical agent. The toxicity responding rate increases as dose increases. By the peak, usually Short-term and long-term tests are conducted in acute toxicity study. I want to demonstrate that this chart is not developed or based on any actual data. It is just a demonstration of the relationship between dose and toxicity response. For the last two slides, I will talk about risk assessment for indoor air pollution. Usually, the step one begins with problem formulation. This includes lung disease, asthma, allergy, neurological, cardiovascular disease, and also the action for reverse those health effect are ventilation, source removal, air purification, and behavior change. The necessary analysis include indoor air risk analysis, cost benefit, and cost effectiveness analysis. In step two, we focus on hazard identification, usually identify risks or potential adverse event source, such as stoves, molds, chemicals, as well as characterizing the probability of adverse effects in the population of concern, such as lung cancer and various impairments are focused. In step three, usually would be conducting a dose response assessment. This include investigating the relationship or patterns between the dose of the indoor air contaminants, such as carbon dioxide, and the probability of adverse health effects. In step four, researchers usually focus on exposure assessment to identify the exposure pathways, how people get exposed to the pollutants, and also find out the tools can be used for measurements of pollutants, as well as collective data, which are associated with health effects. The last step will be risk characterization. In this step, the researcher will be focusing on the natural and the magnitude of indoor air pollutants, as well as the barriers. Those are really important for future research as well. My last slide is a conclusion about outdoor air and indoor air pollutants. There's no specific at-risk population investigated in this presentation. However, I listed vulnerable groups under each associated pollutant category. You can explore them in the first two slides. For outdoor air, I want to underline those 6 key pollutants, which have shown a declining national level trend since 80s, with sulfur dioxide experiencing the largest decrease and ozone the smallest. Those pollutants, including carbon dioxide, lead, nitrogen dioxide, ozone, particulates matter PM10 and PM2.2, are usually affecting people locally across the country. So identifying areas of concern impacted by air toxics emissions is critical for environmental justice concerns. The indoor air, we are the most major pollutants are combustion byproducts, microorganisms, and allergens. Random are main sources. For the control part, such resource removal, ventilation, or modification in air purification are recommended. To conclude, air pollution represents a serious environmental and public health problem, and it's readily across national boundaries to affect areas far distant from the emission sources. In addition, confounding factors such as population characteristics and pollutants have been potential challenges of epidemiological studies, since they have the researcher, those kind of research have the limitation of controlling for other factors. Health adversaries and air clean authorities, such as the Clean Air Act, are essential. Air pollutants are essential for air pollution and control. Uh, my references are here. Here you could see in this slide. I thank you for your time and looking forward to more discussion on this topic. Thanks. Mm.